Good day everyone. In this video, we will talk about real options and other topics in capital budgeting. Based on our previous topics on capital budgeting, we are very familiar with this type of timeline. That in year 1, we have a cash outlay and followed by series of inflow. So the timeline is very stick that the outflow on the year 0 at the start of the project and being followed by a series of inflow. So outlays are done at the beginning and inflows follow. No other actions are done during the subsequent years. But we all know that in reality that this type of setup is not really applicable at all time. Why? Because there are other actions available for the management. For example, if they see the project very promising, then they might have additional investments with regards to that certain project. Now, if they see that the project is not doing a good job in terms of producing profits, they may withdraw from the investment. And if the information that they have as of the moment is not enough for them to assess that the certain project is good or not, then they may delay the investment for a couple of years or they might modify the investment. And these actions available here are just an example of what we call real options. And real option is defined as the right, but not the obligation to take some future action. These actions of additional investment, withdrawal, to delay, or to modify this investment are vested rights to them, but they do not have the obligation to take this action. They might do this if additional information are given to them whether to put additional investment or to withdraw, to delay, or modify such investment. So in this video, we will talk about the three major types or the first three types of real options, and those are the growth options, abandonment or shutdown options, and investment timing options. So we will start with growth or expansion options. If an investment creates the opportunity to make other potentially a profitable investment that would not otherwise be possible, then the investment is said to contain a growth option. Going back to the definition, take note of the word potentially profitable investments. It means that if the company or if the management sees that the investment is profitable, they might add additional investment to the project so that it would create more inflows for the entity. So let's test these real options by comparing a project without growth options and a project with growth options. So for the project with growth options, let's assume this cash flow. So we have two possible outcomes. It could be a good or a bad outcome. So both of the good and bad outcome has an initial outflow of 3,000 followed by 1,515 and 1,500 for good outcome and 1,111 and 1,100 for bad outcome. Both of them has a 50% probability. So let's get their net present value using the WACC of 12%. And so we have here the NPV of the project when the outcome is good is 603, while the outcome of the NPV of the project when the outcome is bad is negative 358. Now, so we get its expected NPV or its weighted average NPV. So we have 603 times 50% plus negative 358 times 50%, and we have 122. So this is our expected NPV of the project without growth options. Now let's compute for the standard deviation. So the standard deviation is 480. So in this video, we will not illustrate how did we get the standard deviation. We already have, it is understood that all of us already has the knowledge of standard deviation. So you might prove 480 using your calculator or Excel there, as long as we know that standard deviation is the standard dispersion between these two NPVs, the 603 and 358 from their mean. Additionally, the standard deviation is computed so that we could have the knowledge about the risk associated with this project. And by that, the standard deviation or the risk that is associated with this project is 480. Now, let's proceed the project with growth options. Or if the entity sees the project good, then they might add additional investments. So we have at initially we have 3,000 outlay. We have 1,500 for the first year. Now, if the outcome is good, the entity wanted to make additional investment. So on the year 2, they have an inflow of 1,500, but since they saw on year 1 that the project is good, and they have additional inflow of 1,000. And so the net cash inflow for year 2 is 500. Additionally, on year 3, the original inflow was 1,500, but because of the additional investment, the inflow 1,500, the original 1,500 is has an extra income of or additional income of 5,000. And so the inflow, if the outcome is good for year 3, is 6,500. For the bad outcome, so it has an outflow of 3,000 and 1,100 for the next succeeding 3 years. So let's compute for the NPV of the good outcome and the bad outcome using the WACC of 12%. So for the good outcome, yes, it has a very large NPV of 3,364. This is primarily because of the additional investment which yielded to an additional inflow for the entity. For the bad outcome, it's still at negative 358. Now, let's compute for the weighted NPV or the expected NPV. So we have 3,364 times 50% plus negative 358 times 50%. And so we have 1,503 as our expected NPV. For the standard deviation, we have 1,861. So therefore, the risk associated with the project with growth option is 1,861. Now, to appreciate the growth option, let us compare the expected NPV and the standard deviation of both project with growth option and project without growth option. So, the expected NPV of the project without growth option is 122 and standard deviation is 480. While on the other hand, the project with option is 1,503 and the expected NPV and the standard deviation of 1,861. If we're going to look at the bare numbers, you can see that it is the project with option which has the highest or the higher standard deviation. But based on our learnings in the statistics, based on the concept of statistics and previous topics on financial management, this is not how we compare two projects because primarily, number one, they have two different investments. On the project with option, we have additional investment which yielded into higher cost of investment. While on the without option, there was no additional investment. On the other hand, the two of them has different NPV and so therefore they are not comparable. So for us to be able to have to compare them in a properly and orderly manner, we need to compute its coefficient of variation. So to compute for the COV or the coefficient of variation, that is the standard deviation over the expected NPV. So we divide 480 over 122 and 1861 by 1,503. And so our coefficient of variation for without option is 3.93 and the coefficient of variation for with option is 1.24. How do we interpret this 3.93 and 1.24? For without option, the coefficient of variation is 393 it means that for every peso NPV, there is a risk. There is a 3.93 pesos risk associated with it. While with the project without option, the coefficient of variation is 1.24. It means that for every peso NPV, there is a related 1.24 risk. And so in this case, we noted that the project with option has a lower risk and at the same time, it has the higher NPV. So we assume and we conclude that this project is the better project. Now, we will compute for the value of the option. So in computing the value of the option, we have these rules. If the NPV of a project without option is negative, then the value of the option will be equal to the NPV of the project with option right away. But otherwise, the value of the option will be equal to NPV of the project with option less NPV of project without option. So, looking back in our summary, we're going to deduct 1,503 and 122. The expected NPV of the project with option minus the expected NPV of the project without option. And so we have the value of the option of 1,318.